Hello and welcome to episode 4 of our Trigonometry Made Easy series. Today we're diving into the cosine rule, a technique that relates the three side lengths of a triangle to the cosine of one of its angles. This versatile method applies to all triangles, not just right-angled ones. Let's jump straight into the statement of the theorem. Given the three sides, A, B, C, and the angle, capital A, we have A squared equals B squared plus C squared minus 2BC times the cosine of capital A. An important thing to be aware of here is the naming convention. Angles in a triangle are labelled with capital letters, and the side opposite each angle is labelled with the corresponding lowercase letter. When applying this result, it's crucial that the side labelled with lowercase a is opposite the angle labelled capital A. The letters B and C play symmetric roles, and they can be assigned to the other two sides in either order. Let's take a look at some examples. In this triangle, the three sides are labelled as 18, 16, and x. We have an angle labelled as 30 degrees. The cosine rule only involves one angle, capital A. In our diagram, we only have one angle labelled, the 30 degrees, so this will correspond to capital A. The side opposite this angle should be labelled with lowercase a, and in our triangle, that's going to be the x. B and C can be assigned to the other two sides in either order. Here, I'll let B equal 18 and C equal 16. The cosine rule states that a squared equals b squared plus c squared minus 2 times b times c times the cosine of capital A. Since a equals x, b equals 18, c equals 16, and capital A equals 30, this becomes x squared equals 18 squared plus 16 squared minus 2 times 18 times 16 times the cosine of 30. From here, we could use some algebra to find the value of x. However, before we turn our attention to the algebra, let's see a couple more examples of forming equations with the cosine rule. In this triangle, the sides are labelled 9.3, 7.2, and x. One of the angles is labelled as 41 degrees. We should label the angle with capital A and the side opposite as lowercase a. The other two sides should be labelled B and C. Here, I'll let B equal 9.3 and C equal x. When we put these values into the statement of the cosine rule, the a squared becomes 7.2 squared, b squared becomes 9.3 squared, c squared becomes x squared, and the 2bc cosine of a becomes 2 times 9.3 times x times cosine of 41. In our final example, the three sides are labelled as 4.8, 10.9 and 8.5. One of the angles has been labelled as x. We should label the angle, x, with capital A. The side opposite, 8.5, gets labelled with lowercase a. The other two sides, 4.8 and 10.9, get labelled with B and C. When we write these values into the cosine rule, we get the following. 8.5 squared equals 4.8 squared plus 10.9 squared minus 2 times 4.8 times 10.9 times the cosine of x. Now that we've seen some examples, it's time to test your knowledge on what we've learned. Successfully applying the cosine rule involves two steps. First, we must correctly label the diagram and extract an equation. Second, we should use algebra to solve this equation. Let's see these two steps in action together. In our first example, we have three sides labelled 9.6, 7.1, and x. We also have an angle of 67 degrees. Well, the cosine rule involves three sides and one angle, and that's precisely the setup we have here. We label the angle as capital A and the side across it as lowercase a. The other two sides get labelled with B and C. Here we have A equal to x, B equal to 7.1, C equal to 9.6, and capital A equal to 67. Subbing these values into the cosine rule gives us the equation x squared equals 7.1 squared plus 9.6 squared minus 2 times 7.1 times 9.6 times the cosine of 67. Even though the right-hand side looks a bit messy, it doesn't involve any unknowns, so we can type the whole thing directly into our calculator. This tells us that x squared equals 89.3055. To isolate the x term, all we have to do is remove the square operator. We do this by taking the square root of both sides. When we perform the calculation on the right-hand side, we find that x equals 9.5. In our second example, the three sides are 5, 6, and 8. One of the angles is marked as x. To begin, we need to label our diagram appropriately. The angle should be labelled with capital A, and the side opposite this angle as lowercase a. The other two sides are labelled with B and C. This can be done in either order. Here, we have capital A equal to x, A equal to 6, B equal to 5, and C equal to 8. Putting these values into the statement of the cosine rule tells us that 6 squared equals 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of x. Solving this equation will require several steps. To begin, we can simplify things by performing some computations. 6 squared equals 36. 5 squared plus 8 squared comes out to 89. And 2 times 5 times 8 equals 80. Now, to isolate the x, there's 3 layers we need to strip away. The cosine function, the multiplication of minus 80, and the addition of 89. To remove the addition of 89, we should subtract 89 from both sides. On the left, 36 minus 89 simplifies to minus 53. To remove the multiplication of minus 80, we should divide both sides by minus 80. To get rid of the cosine function, we should take cosine inverse of both sides. Typing the left-hand side into our calculator brings us to our final answer. X equals 48.5 degrees. To conclude this video, it's time for you to get some of that all-important practice. Try these 2 exercises using pen and paper. The answers can be found in the video description.